Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 12.4, Problem 9. This is Section 12.4, Problem number 9. And we have a function f of x equals, and the function is a fraction. The top of the fraction has e to the x cubed power, and the denominator of the fraction has just x cubed. So this function is a quotient. So the top of the fraction is the u. So e to the x cubed power is equal to u. The denominator of the fraction is the v. So x cubed is equal to v. So when we find the derivative of a quotient, we apply the quotient rule, which says f prime of x is vu prime minus uv prime over v squared. So that's the formula that we're going to use. And when we get to the part of the formula where we have to fill in u prime, u is e to some stuff. So u prime will be stuff prime times e to some stuff. I'll just keep that handy. I'll put that in a box. When I work out the u prime part of my formula, I'll have to remember that's what I need to do to find u prime. So let's start filling in my quotient rule. F prime of x equals, so first v, no prime, just v, just the way it is. That's x cubed. Then u prime. So now u prime, I'm going to fill in stuff prime e to the stuff. So the stuff is x cubed, so stuff prime is 3x squared. Now again, where that 3x squared comes from, the exponent of 3 comes down times the number in front, which isn't written but understood to be 1. So 3 times 1, there's the 3. X to 1 less power. So the third power will drop down to a second power. So that's my stuff prime. And then it's times e to the stuff. So the e to the stuff is e to the x cubed power. So now I'm at the point of the quotient rule formula where I got to the negative. The next piece is u with no prime. So u with no prime is e to the x cubed power. And finally on the end, v prime. Well, v, the denominator is x cubed, so v prime, again, will be 3x squared. The exponent of 3 comes down times the number in front, which isn't written but understood to be 1. 3 times 1 is the 3 again. X to the 1 less power, the third power drops down to a second power. And in the denominator, I have v squared. So I'll have x cubed, put that in parentheses, and raise it to the second power. Now that is the answer what I have written there, but I can clean it up a little bit. So f prime of x is, so the first part of my answer, I have x cubed times 3x squared times e to the x cubed power. The x cubed and the x squared can be multiplied together and make an x to the fifth. Again, when you multiply variables that have the same base, what you do is you add the exponent. So I can simplify and have 3x to the fifth power e to the x cubed. That cleans up the first part of my quotient rule. The second part, minus e to the x cubed times 3x squared, we could leave it like that. It looks a little bit nicer, I think, if we put the 3x squared in front. So I'll just write it as 3x squared e to the x cubed power. And then in the denominator, we had x cubed raised to the second power. With a power to a power, you multiply the exponents. So the 3 times 2 would give me an x to the sixth power in the denominator. And you could still factor out an x squared and reduce it with the x to the sixth in the bottom, because the numerator has 2 pieces Each piece has at least an x squared in it. So we might as well do that. So let's say f prime of x equals, let me pull an x squared out of whatever I have in the numerator. So this 3x to the fifth will become 3x cubed e to the x cubed when I factor out an x squared, minus 3. When I take the x squared out, it just goes away. E to the x cubed. And I have an x to the sixth in the bottom. So the x squared that I took out of the top can reduce the x to the sixth down to an x to the fourth. So f prime of x equals 3x cubed e to the x cubed power minus 3e to the x cubed over x to the fourth.